Go.
We're back. All right. Sorry. Do 12 minutes there. All right. We are so pleased that we have found total energy. See why we went, Alex, you see why we went up to A to do it? Because it was a nice spot. Because there was no kinetic energy. It's
Oh, we
still,
want kinetic energy?
right, because we had to have it, but it was 0 at that spot. So that's why we went there. That's why we went there to find it. So we did MGH, which is potential energy, plus kinetic energy,
Makes sense.
0. So we got total energy very nicely. Nice, neat little package handed to us at point A. All right, but we're not really interested in staying at point A. We want the velocity down here at point B. So let's make an equation about point B. Total energy equals potential energy. Notice how I tell my reader where I'm looking at point B plus kinetic at point B. Total energy is always kinetic plus potential no matter where I am. So it's true, just as true as it was at point A, it's true at point B. But now we know some stuff. We know total energy. We went over to point A and got it. So we'll bring it over here. 6.0 times 10 to the 5th equals, now we need an MGH at B. We'll be able to get that MD, will we be able to get an MGH at B?
Yes.
All right, and will we be able to get kinetic? Well, it's 1/2 mv squared, so we'll know everything except V, which is what we're looking for. I shouldn't circle the squared because we're going to have to get rid of that. All right, so let's plug and chug. Put in the mass, the gravitational constant, the height at B, and put in 1/2 mass, and you'll have an unknown V to solve for. I will put in the numbers, but I'll let you do the crunching. What's the height, 22? All right. All right, check your numbers that you put them in correctly. If you have any questions where any of those numbers come from, you've got to clear that up now. We're at point B, so that's where I always tell my reader where I am in this problem. All right, video land, you crunch away, get those calculators tapping these numbers. We're looking for B. Remember the last step? What's the last step, somebody, always? Well, we're going to square root. Don't forget, the last step is a square root. Because all of this, you multiply this and move it over here by, I guess we do have to work this together. So I have to reteach you about sig figs when you add and subtract, just to make sure you know. All right, so somebody, I'm sorry, we'll slow you down a little. Somebody got the 546 times 9.8 times 22 number? Anyone got that separate?
117,717.
At part B, at point B?
Yeah,
All right, wait a minute, find my work
117,717.
here. Hold on.
Yeah, but sit there.
All right. 546 times 9.8 times 22. Can I write it as 1.2 times 10 to the 5th? Is that the same as what you said?
Yeah.
Is that the same? No?
Can we do it later? Like, not in the problem?
No, we have to do it in the problem because of this little plus sign is going to cause us some problems with sig figs. Let me see. 546.
Oh, this is so nice.
Alright, I get
You could do
1.2.
that. You could do that, yeah.
Where would you
Is it
get?
to the 5th though? Yeah, it
Yes,
is.
it
Alright. Alright, so we're going to have to do sig figs as we go. I'm sorry. But this is, when we multiply this out, we're only allowed to use 2 sig figs. So we have to do, you could write it as 1, 2, 1, 2, 3, 1, 2, 3,
You're
4,
supposed to divide it?
No, I didn't.
5.
Tried to, I just don't know why.
You can write it as 120,000 as well, right?
Just
Okay.
style.
Are you okay, Zach, with
Yeah.
that? Okay.
Yeah, step by
All
step.
right, so now you can write it in scientific notation or this. Both of those indicate two sig figs. All right, what's 1/2?
Subtracted.
5, 4, 6.
I don't know.
Because I've multiplied it to a b squared. So technically you have to divide that before you can add. So you subtract the big number, and then you divide by that number, and then b squared.
Yeah. Yeah.
Okay. Is that what you did?
I think.
273, right? So I'm gonna write that as 270. Who needed that 3 anyway?
Oh, wait.
So when I want 1/2 times 5, 486, I get 270 with sig figs. Now, what's the next step mathematically? So I'm gonna write this without the times. 1, 2, 3, 4, 5. All right. Do you notice on my last row, I have all my sig figs in a row? Mathematically, Zach, what do I do next? Sorry to slow you way down, but I have a point to make, so.
Well, you have to divide by 270 on both sides.
But yeah,
Why wouldn't you?
Why?
Oh, besides that.
we're solving.
Subtract.
Right, subtract. That's what I need to talk to you about. This is, do you recall how to do sig figs when you add and subtract?
It's by the amount of significant digits.
I'm sorry, I can't hear.
It's the amount of significant digits, and that's how many you can take.
What do you mean by number of significant digits? Like,
The
what?
least amount of significant digits.
No, it actually has to do with place value. So, when place value, which number, remember this one was significant, so I'll put a little check over it. You can't tell when I wrote it like this, but it is significant because there's 2 in this number. So this means this is significant to the ones, tens, hundreds, thousands, 10,000ths column. So remember, that's how you do it with adding and subtraction. You look at the column that the number was rounded to. So this was rounded to the 10,000ths column. This was rounded to the 10,000ths column. So when we subtract, what do we get? This. So we have to be similar. We have to be rounded to the 10,000ths column. So this one would have been the same the other way, I believe, but it will make a difference at some of our problems. So when you add and subtract, make sure you check what column your numbers, and you want the least precise column when you do that. All right, so now we have 270b squared. Now you divide and take the square root. I'll let you go with that because the sig figs are normal at that point. So what number came out for the velocity at point B? Did you get one, Emily K, MK?
Hold on. $42.
42, anyone? All right, meters per second. All right, that's with doing the sig figs the way we're supposed to do them. All right, now we answered the question. It's 42 down here. Someone said at the end they think it's going to be slower. So let's see. We're going to do the same process. And this is the velocity at B.
Yeah, okay.
Now we're going to do the velocity
Sorry.
at C.
Sorry.
All
Everybody
right.
has those days.
If you know what you're doing, if you can repeat that, go right ahead. Alex, you help me set it up. So we're going to do total energy. Now we're up here at C. It equals potential at C plus kinetic at C. So I know potential is mgh, and I know kinetic is 1/2 mv squared. So what is total energy? We'll go across. What's total energy in this problem?
Total energy is would it be 6.0 times 10 to the
Right.
3 squared. Oh no, we already know 270 squared.
All right, mgh then. So Alex, what goes
mass,
in?
gravity, and height.
All right.
So you have 5 46
Uh-huh.
kilograms times gravity to 9.8 times a height of 67 meters.
Alright, 67,
Yeah,
alright.
that's 270
Plus
squared.
1/2 mass again.
What?
546
probably was
times
270 squared.
velocity, which is
That's what
42.
That's what we're looking
Oh,
for. And that velocity was
Oh,
only
for
at
B,
point
okay,
B,
right.
so we're looking for a new one. We're expecting it to be less, just from our experience in life.
So
Alright,
360.
Alright, everybody tippy tap. Last step is square root again, so the velocity at C, did it turn out to be lower
220.
than 42?
Wait, hold on.
Yeah.
240,000
It's lower.
equals
Yay.
207.
Wait, so
Alright,
now
so-
that's expected.
Our intuition
Oh, wait, no,
held.
it was more.
Wait, what did I say?
You said it was more.
No, you said it was less.
20,
She said it was
30.
more
I
up
said it was
there.
more up there.
You did?
Yeah.
Yeah, she wasn't.
Okay. I'm sorry, I thought you said it the other way. Okay, our intuition was wrong. Okay.
It was
But
wrong.
remember, the only thing that's pulling
And your
this
intuition.
MD is gravity, right?
Yeah.
So as it comes down here, then it has to get up with the momentum it had. It's not just gonna slow. It
Sure,
should. I
so the
thought you
batteries are
said it correctly. All right, what is it coming out to be? Brian, do you have it?
Let's see.
That's kind of annoying. Like, what happens?
Pardon?
Like,
30, all right,
it's
and we're gonna
probably
write
like
that
the
as
camera
3.0
that shuts
versus
off.
big
I got 30, like
A
20.
lot of like ones will use the battery.
So it's 29 around it.
Yeah, that you should have. That's good. But I have to write it like
Yeah,
that
it's a
to
little-
tell my reader there's two sig
Yeah, you do.
figs. All right,
Feels so
very good. So are you all ready to ride your own
I'm
roller coaster
ready
by
for this.
yourself? All right. All right, if you would turn to your OYO 8.4, we'll work on that.
Oh, which one's your book?
OYO.
it's the turn.
I'm keeping like with so sweet. She was like,
8.4,
Okay, you get my book as well.
8.5,
David and Davey.
and page 285.
We have to stop.
Number 3.
wait, just wait for it.
What is this?
Those are yours.
Give me mine.
You want to split one and one? Is this on?
Yeah.
Alright, let's show them the problems. Can we do that
Yeah, we
before
did.
we turn it off? Because we have time to show them.
We did.
Are you already, I mean, in the
No.
book?
Oh, in the book.
Is
yeah.
it turned off?
It's not turned
If
off.
you didn't
Okay.
show them that
You're,
problem,
you're
so
gonna be a
you'll
little over
fired.
12.
Alright,
but-
you open the book and I'll get a, shine a light on it. 8.4,
What is it?
that's 3, so keep going, keep going. Alright. 8.4. Alright, there's a picture of it. And 8.5. And the picture, sorry, I'm stabbing you. And that's the picture of that. Alright, now we're going to show you number 3 on page 285. Whoops, I guess it's 4. I'll change that. No, oh, it's over here. It is 285.
Oh my goodness, so easy. I know how to do this.
Alright, look at number 3, and we're all set and ready to do that one.
Let me bring you in the dark.
Alright, let me show you what everybody looks like, but I won't show you their heads. Alright, alright, here's student number 1. I can't show your
You
heads.
can't show my face, but you can see my jersey.
Okay,
Who I am.
alright. Yeah, that's great, because your hair is part of
Just edit
it.
it, blur it out, and do the copy.
You don't care. Oh, you gotta stand up. I gotta see the whole. Alright, I won't show you. Cover your face or I won't show your face. Either one. No face recognition
That is
here.
spot goals right there. Guys, we're all related.
Those are awesome. Where do you get those shoes?
We're all like related.
What are those?
I think
Alright,
Brian's
Brian.
related somehow. I think that's your
No face.
Oh.
There you go. Shy person. Alright, you can see the Star Wars theme. Come and see it.
Come on, if you
Bye.
we've all been related.
Alright.